we have seen in compressible fluid flow through nozzles and orifices, we have seen that is mass flow rate through the fluid as well as velocity of the fluid. We have also seen what is maximum flow rate as well as maximum velocity. We'll use this to see what is variation of maximum flow rate with the pressure ratio, and also calculate what is relation of velocity with sonic velocity. Variation of mass flow rate with pressure ratio. Now, we know that the mass flow rate is given as m dot is equals to A2 into square root of 2 times gamma upon gamma minus 1 into P1 into rho 1 into n raised to 2 upon gamma minus of n raised to gamma plus 1 upon gamma. So this is formula for mass flow rate. So we have to know what is a mass flow rate per unit area relation with versus what is a pressure ratio P2 by P1. So this is what we have to calculate. So let us take some random values of these variables. First of all, we'll know gamma is equals to 1.4. Let us consider P1 is equals to 1 bar, that is 1 atmospheric pressure, 1.023 or 1.032 into 10 to power 5, that is value of P1, and density, will consider density of air is 1.2 kg per meter cube, or rather we'll consider this as 1 kg per meter cube, not 1.2. We'll consider 1 kg to be very precise. So now what we have to calculate over here, there are two variables. Mass flow rate per unit area is equals to, that is a square root of this part, that is a 2 into 1.4 upon 1.4 minus 1. P1, that is a value is 1.0325 into 10 to power 5 into 1, and n raised to 2 upon 1.4 minus n raised to 1.4 plus 1 upon 1.4. So this entire value we have. So we have to vary the value of n over here. We have to vary the value of n, and we have to see what is the effect over here. So now what we'll do over here is, in our calculator we'll use the function of equation. So in your calculator you will have a function of equation f of x. We'll substitute this entire equation, that is a square root of 1.4 so on and so forth. Instead of n there will be x, and here also there will be x. Now we'll vary this value from its minimum value, that is 0, to its, let us consider the maximum value of P2 by P1 as 1. Now during this, if you vary this entire value from 0 to 0.1, we can see over there that is this variation we encounter. That is, when n is equals to 0, mass flow rate per unit area is 0. So on and so forth. If we'll go, we can see over here the maximum mass flow rate is 0.632.15 and the next maximum is 362. So that means in this range the mass flow rate is maximum. If we still increase this from 0.6 to 0.5 to 0.6, if we still increase the range between these two values, then we'll get the mass flow rate maximum m dot upon A2 maximum at a value n is equals to 0.528, which we have already seen. Now if we plot this entire graph, so this graph will look something like this. On your y-axis and on your x-axis, there are two things over here. This x-axis is a controllable quantity which is controlled by us, so that is the pressure ratio, that is a P2 by P1, and this is the dependent quantity, that is mass flow rate per unit area. Mass flow rate per unit area is dependent upon the pressure ratio. So if you have this deviation, by calculating this entire part deviation, we can plot this graph as initially this graph will increase and then it will start to decrease. At this point, we can see over here, this is the zenith point, or this is the maximum point over there. So over here, this is maximum mass flow rate. This is the maximum mass flow rate, and this value over here of n2 by n1 comes out to be 0.528. This is 0.528. Now this point is maximum value of mass flow rate. This value is n2 by n1. Initially it increases to a value of maximum. After that it decreases as we increase the value of n2. So this is the variation of mass flow rate per unit area with respect to the pressure ratio. Initially it increases, maximum value is 0.28, then it gradually decreases to, again the value will be 0. So if you consider this as 0 and 1, so here also this first coordinate we have seen, first coordinate over here is 0, 0, which is over here. The second coordinate is 1, 0, so 1, this is a 1, 0. In between this, the pressure ratio is increases, then further decreases from 0.0 to 0.528, and further from 0.528 to 0. Next, what we'll see is relation of velocity with sonic velocity. Now we know that relation of velocity of fluid at outlet with sonic velocity. Now we know over here that velocity v2 is equals to square root of 2 times gamma upon gamma plus 1 into p1 upon rho 1. So we have substituted this, that is the maximum velocity, which we have seen. So p1 upon rho 1. So we know that n is equals to p2 by p1, and value of p1 will be n times p2. So we can substitute in this equation, and rho 1 will be equals to, we can write rho 1 in terms of n and rho 2. So let us see, this is p1 upon rho 1 is equals to p2 upon rho 2 raised to gamma. So this will be equals to, if you take this on the other side, and this on the other side, so we will get this as minus 1 upon gamma into rho 2. Let us see how these values come. So this will be p1 upon rho 1 raised to gamma is equals to p2 upon rho 2 raised to gamma. So rho 1 raised to gamma multiply on the other side, so this will be equals to rho 2 raised to gamma into p1 by p2. So this is rho 1 rho1 will be equals to rho2 into 1 upon n raised to 1 upon gamma. So this will be rho1 is equals to rho2 raised to minus 1 upon gamma. We'll substitute that in the initial equation. So our initial equation states that v2, that is the velocity, is equals to square root of 2 times gamma upon gamma plus 1 into p1 is n times p2 upon value of rho1 is equals to rho2 into n raised to minus 1 upon gamma. So let us substitute this. So v2 is equals to gamma 2 times gamma upon gamma plus 1 into p2 upon rho2. Let us take this in the numerator. So this will be n raised to 1 plus 1 upon gamma. So this will be equals to v2 is equals to 2 times gamma plus 1 into p2 upon rho2 into n raised to gamma plus 1 upon gamma. So we have over here the value of n raised to gamma plus 1 upon gamma. This value which we have seen earlier, this is n raised to gamma plus 1 upon gamma is equals to 2 upon gamma plus 1 is equals to 2 upon gamma plus 1 raised to minus 1. So this will come in the numerator, this will come in the denominator. So we'll just substitute this value. So this will be equals to v2 is equals to square root of 2 times gamma upon gamma plus 1 into p2 upon rho2 into 2 upon 2 upon gamma plus 1 raised to minus 1. If we substitute this, we'll get this as v2 is equals to 2 upon gamma plus 1 into p2 upon rho2 gamma plus 1 by 2. 2 and 2 rho gamma 1 plus gamma 2 will go away, and we'll get v2 is equals to square root of gamma p2 upon rho2. So this is v2 is equals to c2, that is value of sonic velocity. That means when a fluid is flowing, when a compressible fluid is flowing through a nozzle and orifice, its velocity is comparable to the velocity of sound. I hope you have understood what is the variation of mass flow rate per unit area with respect to pressure ratio and what is relation of maximum velocity to the sonic velocity. Thank you.